So if you weren't here yesterday, we did inverses, which we're going to do today again. So don't worry about missing the inverse component. But you did miss the completing the square component. Okay. Now, completing the square has the goal to get it into vertex form. Vertex form is going to look something like this. F of x is equal to x plus 1 squared plus 2. We're going to get in vertex form for another purpose, but for now we're going to go ahead and look here and complete the square for these binomials. There's two of them here, right? We always use the terms that have an x squared and that have the x value in it. If it was like plus 7 or plus 10, we would disregard that plus 7 plus 10. We would go right for these two terms and put them in the boxes here. So I look at this, and someone from yesterday, help me out. What are we going to do with our x squared?
And x goes above the top of square, right?
Like that? Are you going to the next step where you're saying x times x? Okay, good. That's what I was going to ask next.
Sorry.
So, no, there's no sorries. In fact, here's a candy to reward you for moving ahead in time. Time traveler.
Thank you.
Almost snapped. So the reason we have it like this, if you missed yesterday, it's just like a multiplication table. X times x gives you x squared. You see that? X times x, x squared. And then what you do is you take the other term, let's break it in half and put it in the top corners, the top and bottom corners here. So 14x breaks into 7x. 7x. You always break in half. Even if it was an odd number, you break in half, there'd be a decimal, but you can deal with it. So looking at it next, just like multiplication table, what times x gives you 7x? What times x gives you 7x? 7. Positive 7, right?
Yeah.
Same thing over here, because it's x times what gives you 7x? Positive 7. Everyone okay with this multiplication table kind of process? Okay. So then, Emil, what's going to go down here if we have multiplication tables with 7 and 7? What's going to happen down there? 49. Now, if I'm looking at this and I cover 49, raise your hand at the end if you got a candy. Okay, I'll call on you guys in a second. I'll pass them. All right, if I cover the 49, is everything else in the boxes, if we combine them all, would that equal where we started? Okay. We combine where we have here in the boxes, that would equal x squared plus 14. Does that work? Okay, so what did we really change? We went into this system, this equation, and we added what? 49. So if you have $5 and I give you $100, and then I say, nah, I'm just kidding, I need the $100 back. You have the same amount that you had. I hope so. If you have $5, I give you $100, I take $100 back. You got $5, right? You got $5. Okay. So if you gave me $100, I ran out the door. I thought that was the end of the interaction. If we add 49, how do we keep it balanced? We add 49, what else do we need to do? Track. You see this whole system now, this whole system still equals where I started. Okay, so the last bit is to look here and say, well, let's rewrite it. And we have x plus 7 and x plus 7. The outsides are the multiples. Those are the factored terms we're going to use. Because watch, it's going to be x plus 7 squared, because I have two of them, minus 49, and that's my answer. We just completed the square. We got it in the form we wanted. What do you think? You got it? You see it?
Yes, sir.
I want to do just like one other one, but quicker, because that one took, wait, who gets some candy? Come on. Did anyone else answer the question? Yeah. Anyone else answer the question just now?
I answered it in my head.
I mean,
I did it, but it's still on
Which one? That's like
I was like, oh yeah, I know what it is.
Am I wrong?
There were too many. I didn't even hear yours. There were too many. Just everyone had like a quick argument why they should get candy.
Someone yell.
You have to speak up, right? All right, let's do this one real fast because it's slightly different. So put this example too. If you weren't here. So let's do x squared plus 20x minus 7 is equal to 0. So here's the deal. There's a minus 7 here this time. It's equal to 0. That part isn't going to change our course of action. We moved that negative 7 over a little bit so we could focus on these. And now I want you to put those in the box. We'll deal with that negative 7 later. It's actually going to be combined with those leftovers when we have to accommodate it. We're going to combine it with that later. Yeah. So go ahead and put everything in the box here. Let's do it quick. What goes here?
X squared.
10x.
There. 10x.
10x.
Take the 20x and break it in half. All right. So we know that this is going to be x and x. How about up here? X times x gives us x squared.
10. It's going to be 10 at the top and 10 on the bottom left, and it's going to be 100 bottom right square, then -100 in the.
Dang.
Wow, he's smart.
Yes!
Jordan. All right. Next. Here's the deal. We are going to rewrite this as x plus 10 squared minus 100 minus 7 is equal to 0. You see that negative 7 stayed there. It stayed there because we were just looking at one part of it. We grouped it for our convenience. We grouped these two and dealt with it. Completed the square for these. The negative 100 comes from here. The negative 7 came from the term that we left out, and now we got to just combine it. So all together, what's the answer? All together in unison.
X plus 10 squared minus 100
equals 0.
I got that.
You get a car. You get a car. All right. I'm guessing those at home saw most of that. It was kind of cut off until the very end. But now you see it.
Now you know.
Now you know. All right. What should we say for those watching at home?
Why weren't you here?
1, 2, 3. Have a nice day. 1, 2, 3.
Have a nice day!
Oh, that's sweet.